So just extending on looking at using Pythagoras' theorem, I just want to have a look at how to use Pythagoras' theorem to solve three-dimensional problems. Now, this can be really confusing, okay, but it is super important to understand that it is a much more difficult application of Pythagoras' theorem, and it is an extension on those basic skills of Pythagoras. So a lot of people do find it really difficult, but hopefully breaking it down today for you will help you to overcome that. Okay, so when we're using Pythagoras' theorem on 3D problems, we usually need to do more than one application. Now, I know it can be really tempting to try and solve problems as quickly as possible with as little working as possible, but that's not always going to benefit you in the long run. Okay, so it is really important that you take your time and you think about the problem that you're being asked. So I just have a quick example here for us to go through today. So we've been asked to find the length EG and hence find the length AG. So you can see we need to solve two problems. We need to find EG and we need to find AG. Okay, it's two separate problems within the one question. So please don't try and solve it with one set of working out. It's not going to work for you, okay? You're going to confuse yourself and you're going to end up making mistakes. So we can see we want to find EG. So that's the distance from here to here. So looking at it as a flat triangle or a 2D triangle, we've got the triangle EGH, right? So our best bet is to draw that as a two-dimensional triangle. So I've got just a right angle triangle and my lengths on that are, my points are E, H, and G. So you can see I've just copied the triangle from the 3D problem and made it a two-dimensional problem. I'm just going to move that up a bit. So my length HG is 10. My length EH is 10 because it's a cube that we can see, right? So now I can find EG because I have my two short sides. And yes, this is a right angle triangle. So EG squared is equal to 10 squared plus 10 squared. So I'm just applying Pythagoras' theorem using the sides that I have. EG is equal to the square root of 10 squared plus 10 squared. Okay, I pop that in my calculator and I get 14.14. Now I've rounded that to 2 decimal places. Just on a side note, if your question doesn't specify how much it wants you to round, just go to something like 2 decimal places. If you're not asked otherwise, do 2 decimal places. It's enough detail to differentiate between it and another length, especially when you're going to use that value again, which we are. And it's not too long that it's, a waste of your time writing out all those values. Okay, so we've found our length EG. We're now going to need to use that to find AG. So you can see in our cube here, we've got AG is what we want to find. So that's from the back top corner of the cube to the front bottom corner of the cube. So if we were to draw that as a two-dimensional triangle, now I'm going to lose that diagram there, but that's okay. All right, if I'm drawing that as a two-dimensional triangle, I have A up the top, G over here, and E is my right angle. Okay, so AE we are told in our diagram that it is 10. EG we just found, so we're going to use our solution from the previous part, which is 14.14. All right, so now we have our right angle triangle, we have our two short sides, we want to find our hypotenuse. So it's a matter of applying Pythagoras' theorem again now with these new sides. So we have AG squared equals 14.14 squared plus 10 squared. AG is the square root of those, which comes out to be 17.31876. I'm just showing you rounding because it's always a good opportunity to check that you understand how to round numbers correctly, because it is a lifelong skill and it is a skill that many people lack. Okay, so we want to round this to 2 decimal places just to have our detail, but not too much detail. So it means I want to keep 2 numbers after the decimal point. That's where I want to chop it off. The number after where I want to chop it off is called my critical digit. I'm going to underline that. My critical digit is 5 or higher. It's an 8. So what that means for this one is it becomes a 2. All right, so we get 17.32. And of course, I'm going to outline that I rounded that to 2 decimal places. Okay, hopefully that clears a few things up for you. As I said, this is an extension on Pythagoras' theorem. It is difficult. It is a difficult concept to look at, but if I can take you back to the original 3D drawing, it's just a matter of looking at your right angle triangles that lie within that solid, okay? And always draw them out. It makes it so much easier for you to solve those problems. And as I said, don't rush it. Look how much work that took me, okay? It's not an easy problem to solve. It's not a quick problem to solve. Don't try and don't try and rush through it, okay? Hopefully that was helpful. Give it a thumbs up if it was, and don't forget to subscribe to my channel so you get notified when I upload new videos.